Example 2. Is the following argument valid? If it rains, then I will go to town.
No.
Okay, so let's take a look. This is the major premise, and the hypothesis is that it rains. The conclusion we're allowed to draw is that I will go to town.
If it rains, go to town.
All right, so it has to rain for me to be able to conclude anything. Okay, based on that statement, if it rains, there's nothing saying what happens if it doesn't rain, right? So this is what invalid looks like. Notice, it did not rain. All right, which is the opposite of it raining, correct? All right, so that's not saying that it rained, and the only thing I know based on fact in this problem is that if it rains, I'm going to town. That's the only thing I know. Okay, you have to throw out all other thought when you're doing these problems. The only thing you know is this rule right here. This is the rule of the universe that's important to you right now. That's the only thing that you can tell anything about. This doesn't say it, so this is invalid. If you get an invalid, I want to know why it's invalid. So tell me why it's invalid. In this case, it did not rain. Is not the hypothesis.
That's how you want us to do it?
Yep. That's the reason, that's the answer. What this is actually is called a converse. Okay? If you have some category of some if-then statement, if I flip the light switch down, then the lights turn off. Okay? The converse would be if I don't flip the light switch down, then the lights do not turn off. Converses aren't always true. Let's use that light switch one for example to distinguish why this is not true. We all know that if I flip the light switch down, the lights go off, right? There's only one switch, up is on, down is off. So obviously that action is always going to result in the lights turning off. Okay? If I don't flip the light switch down, but lightning strikes the power station that supplies power to this school, what's going to happen to the lights? Right. If I have one light bulb that is controlled by that one light switch, and that one light bulb happens to burn out, what's going to happen to the light?
Turn off.
It's going to go off. Okay? So not flipping the light switch down doesn't necessarily mean the lights are going to stay on. All right? But flipping it down definitely turns them off. So again, with if-then statements, this is the law. If this states the same as that, then it's valid. If it doesn't, then it's not. The only other reason that there might be some invalidity on these would be that, let's say it rains, I did not go to town. I did not go to town does not match the conclusion. So something does not match something. All right? It's basically going to be a reason for invalid on these problems. All right? What if this says, if it rains, then I will go to town. And then I wrote, I went to town, so therefore it rained. Do we think that's valid? Does it seem reasonable? Saying raining leads me to going to town, so obviously if I went to town, probably it rained. Okay, but again, me going to town, it just says if it rains, I'm going to go to town. Maybe if it doesn't rain, I'm going to go to town also. I don't know. I might just like going to town. Who knows? All right, so again, and that would be another reason. If it says, I went to town does not match the hypothesis. Okay, so again, if you get an invalid, give me a reason why. If it's valid, just tell me valid. If it's a categorical statement, write it in if-then form on your paper before you decide valid or invalid. That's what I'm expecting on these problems. They're going to show up for a few lessons. I think I'd put one on a test at some point. This is not the major purpose of this lesson, but it just getting your brain gears working in the idea of logic. That's the purpose of these problems.